Hello and welcome back to another video, and for this video I will be looking at the definition of determinants, that is the direct definition of determinants. But first we must understand permutation and inversion. So we have a definition here: let u equal 1, 2 up to some n be a set of integers. A rearrangement j1 up to jn of these numbers is called a permutation of u. So we have an example: let x equal 1, 2, 3. Now the number of inversions in this set is just 3 factorial. So number of permutations is equal to 3 factorial, which is equal to 3 times 2 times 1, which is just equal to 6. And these can be written out as such: 1, 2, 3, 2, 1, 3, 3, 1, 2, 1, 3, 2, 3, 2, 1, and 2, 3, 1. So now on to another definition, the definition of inversion. So say that there exists some jm and jk in our set of permutation. If jm is greater than jk, and also jm precedes jk, then jk is an inversion. So now for example 1, we have 1, 2, 3, and the number of inversions in this permutation is just 0, since we have no large number preceding a smaller one. So now on for the example 2, we have 2, 1. So the number of inversions in this permutation is just 1, and it is 2, 1. Now for 3, we have the number of inversions in this permutation is 3, 1, 3, 2, and it's 2, so we have 3, 1 and 3, 2. So now on for 4, we have 1, 3, 2. We have 3 being the larger number and 2 being the smaller number, so we have 1 inversion, and that's 3, 2. So now for the other one, we have 3, 2, 3, 1, and 2, 1, and therefore the number of inversions for this permutation is 3, which is 3, 1, 3, 2, and 2, 1. Now on for 6, we have 2, 3, 1. So we have the number of inversions for this permutation is 2, and there are 2, 3. We have 2 1s and 3, 1. So now on to another definition. A permutation is said to be odd or even if it has an odd or even number of inversions. So first permutation had 0, which implies it is even. Second one had 1, odd. Third had 2, even. Fourth had 1, odd. Fifth had 3, also odd. And sixth had 2, even. So now on to a definition of determinant. We have our det A is equal to the summation of all permutation minus 1 raised to the permutation A1 J1 A2 J2 up to AN JN, and our minus 1 is positive if the permutation is even and the negative before permutation is odd. So now for example, So we say if A is equal to this matrix, then find that A. And our permutation 1, 2, 3 is just J1, J2, that is in our definition. That would be J1, that would be J2, and that would be J3, and so on. So it would continue as that being J1, J2, J3, and so on. So now for our definition, let's bring that up on screen. That's that A is equal to minus 1, which is positive, but I like to raise it to the number of inversions, which is 0. So we have A1, 1, A2, 2, and A3, 3, plus negative 1 raised to minus 1, A1, 2, A1, A2, 1, sorry, and A3, 3, and that's negative. So plus minus 1 raised to the 2, and we have A1, 3, A2, 1, and A3, 2, plus minus 1 raised to the 1. We have A1, 1, A2, 3, and A3, 2, plus minus 1 to the 2, A1, 2, A2, 3, A3, 1, plus minus 1 raised to the 3, A1, 3, A2, 2, and A3, 1. And that's our det A. And that's equal to A1, 1. If we expand, we have A1, 1, A2, 2, and A3, 3, minus A1, 2, A2, 3, A2, 1, and A3, 3, plus A1, 3, A2, 1, and A3, 2, minus A1, 1, A2, 3, A3, 2, plus A1, 2, A2, 3, and A3, 1, minus A1, 3, A2, 2, and A3, 1, and that's our det A, our formula for calculating our det A. So now for another example, we have this matrix here and we're asked to find the determinant, and we have that A is equal to 3 times 6 minus 2 times 4 times 3 plus 4 times 4 times 8 minus 3 times 4 times 8 plus 2 times 4 times 1 minus 4 times 6 times 1, and that's equal to 54 minus 24 plus 128 minus 96 plus 8 minus 24, and that's equal to 30 plus 32 minus 6, and that's just 46. But if we had used our method that we know widely, then we'd see that this is our result. We have 3, the determinant of 6, 4, 8, 3 minus 2, 4, 4, 1, 3, plus 4, the determinant of 4, 6, 1, 8. That's just equal to 3 times 14 minus 2 times 8 plus 4 times 26, and that's just equal to minus 42 minus 16 plus 104, and that's just equal to 46. So there we have it, the direct definition of determinant.